Good morning, everybody. Welcome to our first official day of math instruction using our learning. I know this is going to be a weird time for all of us to get used to. This is my first time using these kind of tools. And I know that especially math can be hard to understand if you don't have someone to actually show you in person. So we're just all going to do the best that we can, and we'll get through this and get you to graduation. So before you start, there is a PDF of the note sheet in Google Classroom. So if you do have access to a printer, you might want to print that so you can follow along. If you don't have access to a printer, you might want to just use paper and pencil and just write down the examples and notes as we go. But I do recommend trying to print the notes if possible, although I know that may not be possible for everyone. Another thing is that you are going to need a calculator of some kind. I'm just going to be using the calculator on my computer for now. Texas Instruments, the brand of calculator that we use for our in-class calculators, is working on some kind of solution for Chromebooks so that we could get those on our Chromebooks, but there isn't anything at this moment. So once we get that, we will try to get that to you. Otherwise, if we have to graph, we might be using Desmos or other things. But for now, a regular calculator is fine. However, we do need to be dealing with exponents. So on this calculator, I would need to change it to scientific. You can also use a calculator on your phone, as long as you can do exponents. And then later on in this unit, you'll be seeing that we can do log and natural log, but we won't be using those quite yet. Today, we're just going to be dealing with exponents. So make sure you have a calculator that can do exponents. Okay, so we're starting our next chapter. We're starting chapter 4, which is talking all about exponential and logarithmic equations and functions. So our learning targets for this first section for 4A, I can find key features of exponential functions and I can graph exponential functions. So notice this uses the word functions. We have in previous units dealt with expressions, equations, and functions. So we're going to see kind of the difference between those three right now. And then mostly, though, we'll be dealing with exponential functions. Later, we will be actually solving exponential equations, which, of course, are a little bit different than functions. All right, so starting with expressions, an exponential expression is an expression involving exponents. So that means there is no equal sign. So for an expression, what we can do, assuming there isn't any variables, is that we can evaluate an expression. So when we want to evaluate, for example, this expression 3 to the 4th power, we hopefully already know what that means. 3 to the 4th power means we have 3 times 3 times 3 times 3. And 3 to the 4th power should give us a numerical answer. When we have numbers, our answer, of course, is a number. So 3 to the 4th power is 81. Of course, we can also do that on the calculator, so we do need to know how to use the calculator. Obviously, this one we can do without a calculator, but some of these we can't, so we do need to know how. So 3, this one is the exponent key here. Sometimes the exponent key is a caret button, which looks like this. So that might be what we're using when we're using a scientific calculator. We might see that symbol. So just remember that means to the power of. All right, the next expression is 3 to the negative 2 power. So this one, you have to think back. I know at the beginning of the school year with Miss Reeves, you reviewed negative exponents. So we do have to remember what a negative exponent looks like. So I'm going to make a note of that over to the side, and then we will simplify that. It's going to be important to be able to simplify with negative exponents. So when we have a negative exponent, like x to the negative a power, a negative exponent is not a negative number. It's actually still a positive number, but it's going to be a really small number. So this is actually going to be rewritten as a fraction. So if you see a negative exponent, we can rewrite that as 1 over x to the a power. So what I say is jump the line and switch the sign. So when I say jump the line, I mean make a fraction bar. So that's our line. So this jumps to the bottom of the fraction. And then switch the sign. Instead of this being a negative a, it becomes a positive a. So that's going to be important to know. And we need to know that in order to be able to simplify these two. So 3 to the negative 2 power, this means 1 over 3 to the 2 power. So we jumped the line to the bottom of a fraction, and then the 2 became a positive 2. And so then we know this is going to be 1 over 3 squared. 3 squared is 9. So 3 to the negative 2 power is 1/9. Let's highlight that. All right, next one is 2 to the negative 4 power. So again, that means 1 over 2 to the 4th power. So I jumped the line to the bottom of the fraction, and I switched the negative 4 to a positive 4. Jump the line and switch the sign. So then this would simplify to 1 over 2 to the 4th power. 2 to the 4th power, 2 times 2 times 2 times 2 is 16. So that one, those first three we were able to do without a calculator. And especially for the negative exponents, we're going to probably need to do them without a calculator because if we do them on a calculator, which we can, 3 to the negative 2 power, for example, oops. But it's going to give us a, oops, sorry, I'm using the wrong button for negative. I'm not used to this calculator. Here's the negative button. So let me try that again. 3 to the negative 2 power, it gives us a decimal number. So we don't want to have that as a decimal. That's why we're going to have to do those ones by hand. However, if we look at the next examples, 2 to the 2.8 power plus 3, or 1.06 to the 4th power, or 2.5 to the negative 3 power, all of these we're going to need to use a calculator for, and we will be able to give our answer as a decimal approximation since these have decimals in them. So I do want you to grab your calculator and just practice entering those to make sure that you get the same answer as me so that we know that we can enter those in the calculator correctly. So this one is 2 to the 2.8 power plus 3. Only the 2.8 is in the power. So I'm going to enter that on this particular calculator as 2. Here's the power. 2 to the 2.8 power. And then add 3. So it does 2 to the 2.8 and then adds 3. And I get 9.96. Obviously, this is a repeating decimal or a never-ending decimal. So I'm just going to abbreviate or approximate to, we'll say 2 decimal places. So this is 9.96 was our approximation. And remember, our squiggly equal sign means approximation. That is a good habit to use that anytime we are rounding or approximating. So use your calculator and make sure you get that answer to make sure that you entered it in the calculator correctly. All right, the next one is 1.06 to the fourth power. Same thing, we want to use the calculator since we have decimal numbers. So 1.06 to the fourth power is 1.26 approximately. Now this one, since the exponent was a whole number, we could have multiplied it out without a calculator. We could have done 1.06 times 1.06 times 1.06 times 1.06, and we would have got the same thing, 1.26 approximately. Okay, now this last one is going to be a little tricky because it has a decimal and a negative exponent. So let's think about what this means first of all, and then we will get a decimal approximation on our calculator. 2.5 to the negative 3 power, I know I can write this as a fraction. It means 1 over 2.5 to the third power. So I jump the line to the bottom of a fraction and switch the sign. Now, if I do 2.5 to the third power, it's going to give us a decimal number. So notice I'm only right now in the calculator going to do 2.5 to the third power, which is 15.625. So my fraction is actually 1 over 15.625. Now, we don't usually leave decimals in a fraction, so I'm just going to get a decimal approximation for this. So in this case, I could just type this in my calculator as 2.5 to the negative 3 power. So on this calculator, I have to type the number first and then make it negative. So 2.5 to the negative 3, and I get 0.064. Okay. So that makes sense that I get a really small decimal number because I had a number to a negative power. A negative exponent is always going to be a fraction like this. All right, so those are exponential expressions. There's no equal sign, and when we evaluate them, we just get a number. So that is a skill we'll be using here as well.